All right, today we're going to talk about Swift programming and how to implement asynchronous behavior. Now, we saw that a lot of our colleagues was going over Swift programming, so we're not going to too much talk about, background and the details, the nitty-gritty about Swift. We're mostly going to go over asynchronous programming and how to implement that and how it can be used to, make an application run smoothly and how to basically do it is what we're going to go over in this presentation. Now, Apple made a new language and it is called Swift. It's kind of it's a new language that they developed. Before they used to focus mostly on Objective C with iOS development, and you can still make applications using Objective C. However, Apple has pushed in the last year or so this new language called Swift. It's similar to how Microsoft pushed C Sharp, kind of a language that they can update, make manages to, and expand on on previous applications and making a language that encompasses a lot of things. That's why Swift actually contains a lot of our favorite things from different languages. For example, functional programming, you have map and filter functions. So you have the beauty and the speed of some of those list modification and manipulation functions that we saw in functional programming. And you can see that there's asynchronous programming like we saw in C Sharp and a lot of other cool features that they've adopted from different languages and brought into their own and pretty much packaged it all into one language that they call Swift. Now, what we're going to show you right now is normal thread processing. It's pretty much when the main thread processes all the information and that locks up the screen. As we saw in our C Sharp Asian operations demo, when we pressed the button and everything was being handled on the main thread, the entire screen locked up and you couldn't do anything with it. And that would be a problem if we can only use the main thread in application development. It would pretty much leave your phone entirely useless if you were to just press a button and the phone were to do nothing. So we're going to show you what that would look like on an application if everything were to run on the main thread.
All right. So when this normal button is pressed, it's pretty much just it's gonna call this function, and all this function does is just for some bound that we give it some huge number, whatever this is, 400 million, 4 billion. It's just gonna compute a bunch of things, and it's gonna return a sum. The point is, it's gonna take a while to run. So if I hit this normal button, notice the button doesn't depress. We can't press anything else. But more importantly, our CPU usage jumps up to 99, 95%, 90% ish, and it's using one core to run this task. It's all running on the main thread, so that's why everything locks up, just like Farhan said. When it comes back, we'll see the result. The result doesn't really matter. The elapsed time is 21 seconds. So that's pretty much what happens when it locks up. Now, asynchronous processing, this is pretty much when we want to run tasks on different cores. So the way you do it in Swift is the same way we saw it with C Sharp. You would do async await. Here you do dispatch async, and then whatever you want to process on a different thread, a different core, you do it here. So in this code right here, we just make it do long work. And then if we want to update anything on the UI side, we have to come back to the main thread and make those changes. So right now we're going to run that same demo, except we're going to hit the async button. Notice things don't lock up. There's this spinner button running. CPU usage is at 81%. It's running on one core. Now if I hit async, let's say 3 more times, the CPU usage jumps up a little more because it's running those tasks on other cores, and they're pretty much just going to finish as they want to. It'll probably come back within a couple seconds. But the main point is CPU usage jumps up. We know it's running on different cores, and it'll come back with the same result. First one finished. The counter, no, we just have a counter here to count down how many tasks are still running. So as each one completes, it'll decrement. So it still took a while to run. These things are running in parallel on different threads. and threads are expensive to make. So it's only reasonable that they're taking a long time to complete.
Now we're going to show you a different example where to expand on that idea that we talked about in asynchronous, where a lot of where tasks were running on different threads or different cores. Sorry. We're going to expand on that idea by having a visual aid. Now, what it's going to do is we're going to assign each thread to a core. So it's going to load images that you'll see soon, and it's going to do it in different chunks because it's being done on different cores.
Right. And main point is Swift doesn't actually support any parallel programming. There's no parallel for loop and anything like that. But what we can do is just compute and process data on different cores. Um, so each image pretty much, just every image pretty much represents a salary. What each button press will do is just run a simulation of 1 year in the life of that smiley face, and they'll have a different amount of money. And when it comes back, their faces will change because they made money, but they also lost a random amount of money. So notice the CPU usage is still at 99, 98%. So it's all running on one thread, the main thread. So things locked up, you can't, that normal button doesn't come back. And because it's running all on the main thread, it'll all finish at the same time. CPU usage 0%. So now what we can do is run it asynchronously. First, I'm gonna hit this reset button, make them all smiley again. When I hit this async button, what it's gonna do is it's gonna run 20 simulations on each core. So the faces should update 20 at a time. So now the CPU usage jumped up to 280%. So it's running on all four cores. Um, we'll see the faces update, and as the tasks complete, we'll see the little message down here that the task is complete. Now, see, we can see the faces updating. So some of these people, some of these faces lost a lot of money. They're crying. They're sad. CPU is at 0, so it all finished. All the images should have been updated. Now, because the code has to retrieve the image from each from the table cell, it could take a while. So that's when you have to really choose when you want to run things on separate threads or on different cores. When you're updating anything related to UI, obviously you want to do it on the main thread. Um, that also changes how many threads you want to run. So you have to choose what you want to do wisely.
Okay, as we're gonna see when we hit the normal, we're not gonna hit the normal again because you saw what it did before. But it's gonna just take a really long time. But now let's hit the async button. And as you can see, when we pay attention to the outbox and the CPU jumps to 300% running on all four cores, and it's it's doing all the calculations that it can. Now, as we saw in the outbox, and we know from parallel programming, the task's finished in a different order than we may have assigned it. That's because cores just finish their processing at different times. But we saw that each one of the tasks were finished, but not each one of but the images weren't loaded. As Carlos mentioned earlier, that UI takes a little bit longer to just update, and that has nothing to do with the parallel code. But the tasks finished, and they finished significantly faster and at a much less time than the normal calculation took.
So that pretty much wraps everything up. We showed that running things asynchronously isn't always the best option when you're updating UI and images and collection views, as they're called here in iOS. This collection view of images took a while to update. So instead of doing that, we decided to do this just so we could show that all the tasks finish at the same time, running the same calculations, and it's a lot faster than doing it all on the main thread.